Welcome back to the next session of physical world. Friends, in the previous video we discussed about the fundamental forces in the nature, that is 4 fundamental forces. In that we studied gravitational force and electromagnetic force in detail. Today we discuss some properties of strong nuclear force. Friends, as the name suggests, strong nuclear force, which is the strongest force in the nature. So I write first property, it is a strongest force, in the nature. It is strongest force in the nature. Second thing is, as we discussed in the previous class about the properties of gravitational force and the electromagnetic force, there we said that gravitational force as well as the electromagnetic force obeys inverse square law. That is, as the distance between the two particles or two bodies increases, force decreases, or if the distance decreases, force increases. That we discussed. But when it comes to the strong nuclear force, the strong nuclear force will not obey the inverse square law. So we can write the second property, that is, it do not obey inverse square law. It do not obey inverse square law. The next property of the strong nuclear force is, we said in gravitational force is an attractive force. We say electromagnetic force is either attractive or repulsive. But when it comes to the strong nuclear force, it is always attractive force. It is always attractive force. It is always what? Attractive force. Next, when we discussed the properties of gravitational force and the electromagnetic force, we said that these forces are long range forces. Whatever the distance between the two objects, there will be a gravitational force, there will be a electromagnetic force. But when it comes to strong nuclear force, it is not a long range force, it is a short range force. That will be the next. It is a short range force. It is a what? Short range force. The next property is, as I said that in the strong nuclear force, in gravitational force and in the electromagnetic force, we said that the force is conserved. But conserved means what? It's neither be created nor be destroyed. But when it comes to the strong nuclear force is a non-conservative force. It is a non-conservative force. And then if you compare the capacity of the forces, as we said that, as we discussed that gravitational force is the weakest force in the nature. When we studied electromagnetic force, then we compared the electromagnetic force quantity with the gravitational force. We came to know that gravitational force is 10 raised to plus 36 times lesser than the electromagnetic force, or electromagnetic force is 10 raised to plus 36 times greater than that of the gravitational force. Then if I compare electromagnetic force with a strong nuclear force, if I compare gravitational force with a strong nuclear force, how much it is stronger? As I said that it is the strongest force in the nature. Then if I write the next property, I can write here, it means strong nuclear force is 100 times stronger than, it is 100 times stronger than electromagnetic force. EM force means electromagnetic force. Similarly, if I compare with the gravitational force, already I said it is 10 raised to 36 times stronger than the gravitational force. So 10 raised to 36 plus 10 raised to 2, that is 10 raised to 38 becomes, then right, it is 10 raised to plus 38 times stronger than gravitational force. Gravitational force. So these are some important properties of strong nuclear force. Friends, again, if I come to the examination point of view, then question in the examination will appear on this topic is, it may be, name the strongest force in the nature. Our answer is what? Strong nuclear force. Compare the strongest force with the electromagnetic force and the gravitational force, or name the fundamental forces in the ascending order or in the descending order. That table I will send to you personally and in the form of PDF file. Then you can copy that table, and in the examination time how to write in the ascending order, descending order, I will explain. Next thing is, in the examination they may ask name the strongest force in the nature for 1 mark, question number 1, part A, or else part B, question number 11. Mention any 2 properties of strong nuclear force. Out of 6, 7, you can write any 2 of it. Then let's go for the fourth one. Fourth one is weak nuclear force. Weak nuclear force. So here we are writing the nuclear force. As the name suggests, weak nuclear force, don't come to the direct conclusion that it is the weakest force in the nature. No. It is even stronger than the gravitational force, approximately 10 raised to plus 13 times stronger than the gravitational force. Friends, then why should I study the weak nuclear force other than we studied already the strong nuclear force? Because in the nature, if you see your periodic table, at the beneath of the F block, E block elements, there is a lanthanides and actinides are there. These lanthanides and actinides are the radioactive elements. That means when they are subjected to the nuclear bombardment, or when the strong moving nuclear bombards or strikes, then what happens? These nucleons or these nucleus will break up into its constituents nuclei, called as daughter nuclei. So in this process, some particles will be released, right? Especially if I go to the beta decay. Beta decay. That means if a nucleus or called as mother nucleus, when it dissociates into its daughter nuclei, at that time, if it gives an electron, then the electron decay itself is called as beta decay. In this beta decay, you will come across the weak nuclear force, and this weak nuclear force is existing between leptons and mesons. You may ask, what is beta decay, what is leptons and all? These are the nuclear particles. That means what? Till date, you know only certain things about the atoms. Atoms means what? It is consisting of nuclei at the center. Electrons are revolving around it. One thing. Nucleus is a positively charged mass, condensed or mass located at the center, and electrons are negatively charged and rotating around the nucleus. One thing. Good. At the same time, if you go to the nucleus is consisting of 2 particles basically, neutron and protons. Neutrons are electrically neutral and protons are positively charged. Only these 2 particles are there? No. There are many particles are present inside the nucleus. They are named as leptons, neutrinos, mesons, pi mesons, etc. Many such particles are there. Don't worry if you you won't follow these things, because you are going to study these topics once again in second PUC in modern physics. Don't worry about this, right? So with this, we don't have even detailed properties of this weak nuclear force. Hence, so we are not having any properties, not more than this. So with this, I am concluding all the 4 nuclear forces in the nature. Afterwards, we'll come to the next topic called as nature of physical laws. Friends, whenever we study certain things in the physics, they follow a particular law. Whenever we study any phenomenon that follow a particular law or a system, let us say mass, let us say charge, let us say angular momentum, let us say linear momentum. So don't worry to follow these words, because we are going to study this topic in detail in the next previous chapter. This is just an introduction, don't worry, right? So now, if we want to study about these systems are remains same, remains unchanged, alright? If they are isolated by the system, we may ask, then what is meant by isolated system? Isolated system means what? Isolated system means it is a system consisting of n number of particles or the bodies which are remains unchanged. I can write here. Let's say isolated system. Isolated system. Isolated system means what? It is consisting of number of, you can say, particles or bodies. Okay, and keep it in the mind, they are remains unchanged. Right? Okay, say conserved. So now, if you take the conserved quantities, so this is one is the isolated system. Let's go to the conserved systems. Just a few minutes back I explained about the conservation, right? What is conservation? Conservation means it is neither nor. That thing should be in your mind. It is neither be created nor be destroyed, because the entire system remains constant, remains same. It will not be affected by any external force or the time, something like that. So now let's go to the conserved system. In the conserved system, what happens? These systems are remain same, not unchanged, even with respect to the time. In this, we are studying conservation of energy. Energy neither be created nor be destroyed. Conservation of charge. Charges neither be created nor be destroyed. Conservation of energy and the momentum equal to mc square. That is given by Albert Einstein. That means mass and energy are interconvertible. Interconvertible means mass can be converted into energy. Energy can be converted into mass. I will explain in detail afterwards, step by step. Then conservation of linear momentum. That means what? So if I multiply mass and velocity of the body, then mass of the body, velocity of the body, then I will get the momentum. That momentum is again conserved in a isolated system. In this way, we are going to study certain things. After that, we will come across certain laws called as unification laws. Unification laws means basically we studied 4 fundamental forces. In these 4 fundamental forces, we are going to merge or inculcate these fundamental force, one fundamental force with the another one. Albert Einstein tried his level best till his last breath to inculcate all these 4 fundamental forces, but he failed. But nevertheless, he inculcated electronics or electron or optics and the modern physics or the atoms. That gives rise to another law that we will discuss later. Later, one of the James Maxwell, he unified electron theory or electricity and the magneticity or magnetostatics. Together he merged gave rise to the new branch of physics called as electromagnetic theory. That is one more unification. That means electrons and these are merged. And one more Pakistani scientist by name called Abdus Salam. He unified weak nuclear force with the electromagnetic force, naming is a weak weak magnetoforce, or for this he awarded Nobel Prize in 1983. So with these fundamentals, with this I am introducing the physical world to you all people. With this I am completing the chapter 1. Just friends, don't worry, it's a very simple chapter, so you should concentrate only on these fundamental forces. Along with this, in your textbook, so at the end of the book, they have mentioned some pioneers of physical world or physics, that is researchers and their research work, inventors are their inventions, discoveries and who discovered those things. So such things are given in the table. So let's example, who invented electrons, who discovered nucleus, so who invented the television, etc. Such type of inventions, pioneers, I can say pioneers. Such pioneers are mentioned in the book. You just go through those table. So one or two question may be asked in the CET or else in the examination. So with this I am concluding the chapter. Friends, after this end of this chapter, you will be getting a PDF file of this format of this chapter. So just wherever I tick, wherever I sign, that topic only you have to copy. Unnecessary, don't write unnecessary things in the text or in the notebook. Thank you.